Hello, everybody. Wherever you are, you're welcome to the TaiyangNews webinar, What's Hot in Advanced Solar Module Technology. This is the first report we're hosting this year. It is based on a report we published end of last year. We've updated some of the data, and we'll discuss what's going on in module technology. There's a lot of exciting stuff. For that reason, we have on the one hand Shravan Chunduri, who is our head of technology and the lead author of the reports we're publishing at TaiyangNews. And we're also happy to have Winfried Wahl, who works for LONGi Solar Technology GmbH. That's a Germany-based subsidiary. And Winfried is the head of product management and the chief engineer of LONGi Solar. So the focus is advanced technologies. First presentation will be given by Shravan. Second presentation will be given by Winfried, and afterwards we will have a Q&A. We have 1 hour. I'm very much looking forward to the presentation. Shravan, who is in India and joining us from there, please go ahead.
Okay, thank you very much, Michael, for the great introduction. Hello, everyone. My name is Shravan. I'm going to talk about, what's really hot in advanced solar module technology. Men, can you start the presentation? Okay, great. Okay, so today I'm going to talk about this, advanced module technologies that are really hot in module manufacturing. And, before going into my presentation, I would like to take this opportunity. Can you move to the next slide? Yeah, so, I would like to take this opportunity, to provide a brief introduction of our company. TaiyangNews is an open platform. We publish reports on advanced PV technologies, and we also publish market surveys on various production equipment, process consumables. As you can see here, in 2017, we published 9 reports, and in 2018, we published 7 reports. And advanced module technology. Move to the next slide. So, before going into the details of my presentation, I would like to, emphasize that what I actually meant by advanced module technology is that, the basic structure of the module does not change, but a little tweaking results in power boost. So, as to the question of what really motivated us to do this report is that in past, module makers were often relying on improvements at cell level to improve the module performance, but this is really changing slowly. And as you can see that, module makers are now very active in employing innovative approaches to improve the output power of the PV panels, independent from the cell level. Module efficiencies of power ratings are continuing to go up, with PV manufacturers working in several advanced module concepts. And a sure indication is increasing cell to module performance ratio, and then increased number of bus bars. Industry has shifted from 3 to 5, then 3 to 4, then 4 to 5. Few are even evaluating 6, and some even doing multi-busbar. So all this put together, if you see that module making is becoming increasingly interesting and innovative. Next slide. So Unfortunately, I could not show you a slide, but if you can go to our previous advanced module technology report, there you could see that we try to see the trends in the module manufacturing, and what we observed is IBC, which has been the main premium technology. It kind of stayed on forefront in terms of efficiency. Companies like SunPower, LG, who have been selling modules based on this very high funder technology, were always on the forefront on the commercial efficiencies. But what we have also observed, unfortunately, I cannot show that slide here, but some advanced module technologies like shingling, Halfcells, and Multibusbar, any different combination of these, the power rating is not really far apart from the premium products. So what I would like to emphasize here is advanced module technologies are really making a good progress and are also becoming increasingly competitive for very premium technologies. So then some module makers are also using larger cell formats. This is also one interesting way of improving module output power. But technology wise, actually module makers are mainly focusing on 6 advanced technologies. As you might all know, like one is more number of bus bars, then multi-bus bars, glass modules, bifacial, half-cut cells, shingles. So 4 of them are really reducing the resistance losses, while glass is not really about improving, is not about the power, but it is about improving the reliability, and a key enabler for the bifacial technology that enables absorbing the power from the rear side. Next slide. And the beauty of these advanced module technology is also they are really intercompatible. So that means one can, in principle, combine any of this technology to any of the other technologies, and you will get a real 1 + 1 = 2 kind of effect. So when you combine with bifacial with shinglings, or Halfcells, more number of bus bars, and multi number of bus bars, so the net result is really added up. So that's why in the coming slides you will also see that you will only see what we try to do here is we try to put the latest module data from only one particular category, because combining them will really make it very complicated. So just to give you a idea how each of this module technology is independently functioning. So that's why in the coming slides you will see the module power ratings from different companies with only from the selective companies. Next slide. So as you all know, industry increasing the number of bus bars is nothing new. There is a complete shift from 3 to 4 bus bars around 2 years ago, and then a lot of people have also moved to 5. What I hear is around 60 to 70% of market is really doing 5 bus bars, and very few companies have shifted to 6. But I think only Qcells is a publicly known company which is doing that. But some people, nearly 5 is most of the industry is really moved there. And all leading stringing tools suppliers are offering two tools to support this move. Like most of the suppliers, they have kind of a retrofit arrangement. If the stringer is not really old, then they can do the upgrade of this going to higher number of bus bars. And it is the most simplest way to reduce the resistance losses. Next slide. Taking the idea of more number of bus bars to the next level lands into the multi-bus bar arena. Here several of thin copper wires are used to interconnect instead of ribbon strips. the approach actually helps in reducing the finger width, which cuts the shading losses and lowers the paste consumption. And the multi-busbar approach also employs busbarless cells. So this is yet another silver saving factor. And when it comes to the real processing of multi-busbar cells, there are mainly two ways. So one is Meyer-Burger's smart wire connection technology, and another one is simply following the stringing method, which was originally developed by Schmela, but then a lot of stringing equipment makers are offering these solutions for multi-bus bars. And according to our knowledge, a lot of companies are really seriously working on this approach. Next slide. Yeah, so here what we try to do is we try to plot the different power ratings of only multi-bus bar modules from very selected companies. So as you can see, LG has been offering this multi-bus bar technology from few years. So their module has a 400 watt output, and it has a 19.3% efficiency. And then Solar Tech Universal, which is based on heterojunction technology. LG is taking the route of soldering method, and Solar Tech is one example that is using smart wire connection technology. So their heterojunction cells with 60 cells module got a 320 watt output power and 19.6% efficiency. Then GCL is also one company which is really very strongly working on, and its monocrystalline module with 72 cells got 375 hours label wattage, and their 60 cell module got 320 watts. So actually commercially available modules are a bit less, but if you go to any of the exhibitions, you will see a lot of prototype modules. That means a lot of companies are really working at the background about on this technology. Next slide. Then glass module is nothing but replacing the backsheet with the glass. The primary benefit is the lowest degradation from 0.7 to 0.45% per year. So this is it's there is always a discussion whether it's proved or not, because some people claim that this is not true, and glass modules even have issues. But I think this is mainly said by the backsheet companies. So but right now, the most of the module manufacturers who are offering glass modules are confident enough to offer 30 years as a warranted lifetime. So the definite advantages of glass modules is provide heavy duty solutions for harsh environment, high temperatures, high humidity, high UV. And when it comes to the change required for the glass modules, usually the glass bifacial module, glass backsheet modules use 3.2 mm glass, whereas the glass modules are typically uses thin glasses. So some are using 2, some are 2.3, then some are 2.5. So there is a chances of reducing the glass thickness. And even if you are reducing the glass thickness, still glass modules are about 20% heavier. But I think this is about 20% increase in warranted operation time is a big benefit for the customers for the glass modules. Next slide. But one of the key benefit of the glass is, it is a key enabler for the bifacial technology. So bifacial, as we all know, it opens the rear side for the sunlight absorption, which is a major change at cell level, but also has few implications for the module level. Nearly all advanced cell architectures are bifacials. That means if you move from BSF to any advanced module technology, any advanced cell technology, it is entitled for bifaciality. And the change required for the at the module level is one has to employ a transparent rear cover. It could be it is actually glass right now, but it could be also a transparent back sheet. Another change is moving the junction box to the sides is optimal, but it is not really must, because the mismatch that would account to the power generation is very low. So some people are moving it to the sides, but some are really keeping it the same. And the gain in power yield varies between 5 and 30%, depending on the site albedo, device design, mounting conditions, and several other factors. So one interesting recent development in this glass bifacial technology arena is backsheet companies are increasingly coming up with transparent backsheets, so that they can really fight with glass. And for example, DuPont, one of the leading supplier of the components for the backsheet, they came up with a transparent Tedlar. So then most of the advantage is most of the module manufacturer would not change, and weight, which is considered to be a disadvantage with the glass modules during the installations, can be eliminated. But glass followers still say that it's still a plastic, and the transparencies are not very high. But using transparent backsheet also has an advantage that the operating temperature of the modules can be reduced, up to 2 to 5 degrees compared to the glass backsheet technology. Actually, TaiyangNews has published its second bifacial report last year, June, and we will again do that and release a fresh report about the about the bifacial technology at the Intersolar. Next slide. So here you can see, of course, the market is really flooded with a lot of bifacial modules. So we here only took a selective companies. One of the important aspects of the bifacial technology is what is also bifaciality. So bifaciality actually ranges depending on the technology. Like for PERC, it is about 70%. To heterojunction, which is also 95%. So for example, if you see on the right corner, so this is a Sunpreme heterojunction module. It has a front power of 380 and rear power at STC. So this is really the STC measurement. So there is a bifaciality of 95%. And then there are also PERC cells from Jollywood, and they have around 85%. And LONGi, for example, they also have a bifaciality of 75%, and I think a lot of companies are mixing the bifacial technology with few other technologies. So that's why you won't see a lot of other products listed here, because these are really the only bifacial modules from the selected companies. So this is purely bifacial modules. So bifacial is really a good cell technology that has a strong impact on power characteristics of bifacial modules. Next slide. Then another interesting segment of advanced module technology is Halfcell. So Halfcell is nothing but slicing the cell into two pieces. Halfcell technology actually relies on the principle that when you cut the cell into two pieces, it actually reduces the losses by 1/4. It's very simple, very easy technology to implement. It provides an instant boost in power by about 5 to 6 watt. It can be more effective for advanced cell concept with high current, such as bifacial. So it's apparently it's very interesting combination for the bifacial. The flip side of the half cell concept is it reduces the throughput of the stringer by half and needs an additional laser station. However, the development in the recent times that has taken place in module manufacturing equipment, especially the interconnection equipment, that they became so fast. Now this pinch of reduced throughput is not felt anymore. So really lot of companies, module makers, when even if someone is really trying to build a new module line, everyone is really considering half cell as one of the options. So this now every stringer company, every leading stringer company is able to offer this retrofit for processing half cell. So it's really one of the most interesting and less complicated and technology that can result in good power boost. So overall, the cost of the technology at per piece level is slightly high, but on the watt basis, it's really the same. Next slide. In the next slide, you will see the module power ratings of different companies. So most of them, and then as I said in my earlier slide, like these technologies can be combined with good cell technology. So where you have high power, then it's the benefits are really more. Okay, so these are the power ratings from 60 and 72 module configuration, cell-based module configurations. So Jinko Solar actually has a very high module power rating, but this is also because the company uses a larger wafer format. And next slide, please. Then Shingles is another interesting concept. Actually, it is a superlative or superimposition of half cell, taking the half cell into the next level. The cells are interconnected directly by placing them onto each other, similar to very similar to the roof tiles. And unlike in half cells where only cells are stripped into two, here they are stripped into several pieces. And the advantage is it gives a very nice look because it eliminates the use of ribbon. Actually, the interconnection is a bit complicated and requires high-tech lasers and conductive adhesives, but it definitely attracted the interest of a lot of module manufacturers. And but the problem is there are also potential patent issues. This was SunPower is one company which is holding the IP for it, and there is another company, Solaria, and few companies have taken the technology for license, and the products are available in the commercial market. But however, okay, next slide, please. So these are the power characteristics of typically shingle modules available in the market. But a lot of companies have also worked on this technology. In the background, they are showing at the various trade fairs. But I think since the patent, the IP is a sensitive issue, they are not fully promoting it commercially. So for example, but however, Canadian Solar is one company is offering very high power for their PERC cells with 415, and again Canadian Solar is also using larger wafer formats. So that's also one of the trick they're using to improve the power of the module. Next slide. Then, as I said earlier, so all these module technologies are really can be combined with other technologies, and a real best good combination is bifacial and Halfcells, then bifacial multibusbar, because these two technologies really help in reducing the current losses, and bifacial is all about increasing the current, because you have both the surfaces readily absorbs the sunlight and convert into power. So a lot of companies are working, and few companies have even moved exclusively with bifacial and half-cut cell technologies. And another interesting combination is also like multibusbar and Halfcell technology. This is also very interesting technology. Next slide. So here I come to my conclusion. According to our research, we found 6 advanced module concepts: double glass, bifacial, half cells, shingles, more busbars, and multibusbar. And every concept has its own set of advantages, but also requires a different degree of changes in production. Effort to go to multibusbar is very low. And so is the benefit even for the higher levels. Multibusbar, in addition to higher power gain, the technology also saves silver paste at the cell level, but interconnection is a little bit complicated. Of course, the tools are available. Double glass has nothing to do with the power gain, but it really offers a extended warranty power span, warranted span to 30 years, and it's also a key enabler for the bifacial technology, which really has comes with the advantage of increasing the power yield by 5 to 30% depending on the cell module. Decent instant power boost. Shingles is a extrapolation of half cells, both in terms of effort as well as a power boost, and you know, these technologies are highly complementary, and you can mix, you can do a lot of mix and match. And so though there is not a very clear, but a lot of companies are combining bifacial with half cells or multibusbar, more on the half cell side. Actually, what we have seen so far is most of my slides regarding the module power, they were referring to very few and selective companies. Actually, if you go to our previous study on advanced module technology, you will see you would see a lot of data points from different companies and different module products. And we are going to repeat the same, and we are going to do again an extensive study about modules and advanced module technologies and release the report at REI in New Delhi, India, which will be held in September. And I would also like to take this opportunity to thank our sponsors of our study. So next slide. So LONGi has been our greatest supporter, and Meyerburger, Kron Material, APYA, Jollywood, Herios, TV Rhineland, and SNEC 2019. Thank you very much for your attention.
Thanks, Shravan. Nice and comprehensive summary. As Shravan said, actually, since the report was released last year, we have taken actually only data from some select companies and updated them. So if you want to have a broader database, please go to our old report. It's not completely fresh anymore, but at least you see more data points. And as he said, we will update the report actually for REI in September. Coming to the next speaker, while Shravan gave an overview actually on different technologies and different companies. We are now focusing on one company which is leading edge. It's the group is not only the biggest mono wafer manufacturer in the world, it's now also one of the largest module manufacturers in the world. You probably all also just read the 5 gigawatt module capacity launch recently. And Winfried Wahl, their technology head here in Europe, will let us know how LONGi's latest module product developments in the advanced field look like. Winfried, the floor is yours.
Thank you, Michael. Good afternoon, good morning, good evening, dear ladies and gentlemen, wherever you are on the planet. Thanks for TaiyangNews to the great opportunity to speak on the latest advanced module product developments. And as Shravan already said, the process in new technologies has gained speed over the past 2 years. Products and technology approaches differ much more than they maybe ever did, and leaving the challenge to the manufacturer to choose what is the best approach for the lowest LCOE solution. It makes it exciting for all the R&D people. They have a bunch of things to study, to invest. There's a huge number of paths which you could choose. And I would like to give you in a few slides as well the paths we have been choosing where we believe is the most effective way. Next slide, please. But before we go into the technology, please allow me a few slides about our company. LONGi has been founded in 2000. It's already 19 years ago, but most of the time until 2014, we have been focusing on ingot and wafering. And since day one, we have been 100% dedicated to monocrystalline products, which at the end seems to be a good choice. Since 2014 only, we entered into the cell and module business. But as you may have heard, in 2018, we have now a capacity of ingots and wafers of roughly 30 gigawatts and capacity, and the module capacity in the meantime has as well reached to 12 gigawatts after the last opening of the new factory. Next slide, please. Here's a little map of our production sites including our capacity information. Our company is headquartered in Xi'an, China, and the company has production sites mainly in China, but as well in Malaysia and a plant in India, which is very close to where Shravan is today. Next slide. In regards to PV module shipments, if you add capacity, it's not a surprise that as well you step up in the module shipments ranking. More than a year ago, in 2017, we have been number 7 by module volume shipments. Last year already, we stepped up to number 4. You see a lot of the brands which have been in the report from TaiyangNews as well around us. And if you only look at mono, LONGi Solar is the largest shipper in monocrystalline products. No surprise, as we are only producing monocrystalline products. Next slide. Just as an indication for financial health, which is as well something which is a highlight for LONGi. We are not just a volume producer, but at the same time we are growing. We still are very healthy from a financial perspective, which is maybe a good indication that we have not done too many mistakes in the past, so that we still have cash and are able to earn money with our products. Here in the Bloomberg New Energy Finance Altman Z score, we are listed number 1, and the red dotted line is more or less an indicator of companies above or having a bar higher than this dotted line. They are healthy, they make profit. The ones which are under the red dotted line do losses. So that is something which you may find unique, growing, getting large, and at the same time still making profit. Next slide. And due to the fact that we are doing profit, we are able to invest strongly into R&D. From 2012 until half year 2018, we have spent almost $500 million in R&D, and R&D has the difficult part or the funny part, however you like to see it, out of those huge number of different technologies which Shravan already mentioned, to find out which is the most valuable, which is the most promising way, the best platform for the company success. Next slide. And if you do good R&D, then as well, it's not a surprise that you as well will come out with some good results. I just want to mention a few things here, that in January 2019, we could prove cell efficiency world record above 24% on a bifacial module. Already early last year, we could prove on a 60 cell module 360.3 watt, and in November last year 2018, another record, which was module efficiency based on mono-PERC half cut of 20.883%. Let's use this slides for, let's say, introduction for those who don't know LONGi yet, because I think in Asia Pacific, LONGi is much more known than in Europe and in the US, because we have been just active in more or less since 2 years in those markets. So please forgive me to spend some time to introduce the company highlights to you. When we move to the next slide, I will give you our best approach with today's products. Next slide, please. Which we call HIMO3. HIMO3 is our internal marketing name, but I will decode it for you. It is using mono-PERC cells. It is using half cut. It's using double glass. It's using bifacial cells. And the combination of those 3 features, which Shravan mentioned in his report, that they perfectly are combinable into one product, that results into the HIMO3 product. We have been choosing, or why we are choosing mono-PERC, I will show in the next slide. But as a teaser already, one of the key points of mono-PERC is a very high efficiency. Mono is higher efficiency than multi, and PERC as well delivers a huge step up. Mono-PERC offers a low temperature coefficient on power, and it has great weak-light performance. Half cut, I will go into some details on some of the features of half cut. Some have been already mentioned, like lower substring current, lower operational temperature, and I will give you as well some benefit in regards to partial shading. The bifacial design is Shravan mentioned already. There's a huge difference in how big the bifaciality is. Our products have something like approximately 80% bifaciality, and that allows you to get 8 to 15%. We are very conservative here, giving that number higher yield by having a second side, which additionally can create power. The lower operational temperature of double glass and bifacial design has already been mentioned. Next slide. I've listed here slightly different than TaiyangNews has done it in their report, different platforms. And the graphic, which is actually taken from InfoLink, gives you 2 kind of information. The yellow bars is the expected efficiency, where you can lose the scale on the left side. and the gray and the black dots are the cost information or the sell price. It's a little bit different to differentiate. And if you're now very excited research engineer and you have different options available, then the very difficult question is which one to choose. And let's just have a look that starting from the left side, multi-PERC compares to mono-PERCs. They apparently have a very similar cost. So there's not a cost difference between mono and multi-PERC, but mono-PERC offers you a 10% higher efficiency compared to multi-PERC. If you go one step more to the right, then N-PERC, which is based on N-type material, then you can see that the cost is slightly higher, and at the same time, what you get on cell efficiency is a little bit less what you can achieve over mono PERC. Going to add TopCon to the N-PERC mainly blows up your cost by another 7-8%, and what you gain on cell efficiency is less than what it costs you. The next bar or the next element there is heterojunction. Heterojunction, you maybe slightly achieve a little bit more than doing mono PERC, but again, the cost is significantly higher. And from a today's perspective, it seems that IBC technology is a premium product in both, especially in cost situation, but as well on efficiency. And our strategy is to choose the material which is offering the lowest LCOE. That means with the least premium cost, if there's any, to achieve the best cell efficiency at the same time. Otherwise, you would maybe end up in a premium product with a very high cost, and this doesn't really match to what we are doing. We are a mass producer with 12 gigawatt capacity. If we would be a smaller company, then we would maybe take a different decision to go with a premium product only. But as we are doing mass rollouts and adopting those technologies for most of our products, it is clear that we have gone the way with mono PERC. Next slide. The next slide is if we agree that mono PERC has been the best choice from the given reasons before, we have been adding half-cut mono to the PERC technology. And one of the reasons, beside of the ones already mentioned, is that operation temperature of a half cell module is around 2 degrees lower than the operational temperature of a full cell module. And this becomes of essential importance the higher the currents get in the modules. It has maybe been not so significant some years ago when the currents have been lower, but the higher efficient the advanced module technologies get, the higher the currents get, the more it is significant that the currents in the module are managed. And this is as well true if, as it has been already indicated, as a trend, the cells and wafers are getting bigger. And if you visit us, for example, on the Intersolar or SNEC, we will as well show a module which has something like 10% higher cell surface, and therefore as well 10% higher currents. And then it becomes really essential that you can manage the currents in the module correctly. Next slide. One of the other benefits out of a bunch of more, but as well, is how you can deal with partial shading. At the end of the day, the module, half-cut module, is split in the top half and the bottom half. And if you shade some area of the module by whatever, a bird drop or some obstacle landing on the PV module, or as well maybe shading from a neighbor row of your solar park, then it is essential that you can deal with this shading. And one of the great benefits of half-cut is that if there is something happening, a shading, let's say a bird drop, then first of all, if you look at the slide on the graph on the left hand side, the module temperature on a hotspot at the hotspot place is not getting as hot for a half-cut module than it goes for a full cell module. The difference there is in the neighborhood of 10, 15, sometimes up to 20 degrees Celsius. And if you look on the right-hand side, then there's a graphic shown where the proportion of shaded area in regards to the hotspot temperature. The red graph is the one using a half cell module, and the black graph is the traditional full cell design. There as well, you can see what I said initially. If there is some shading, the maximum temperature will not be as high as it is on the full cell module. But as well, if you have, let's say, a shading effect just on half of the module, on the lower part, let's say, the top part will still perform at maximum performance. So the impact is much less than if it is with the traditional design. Let's go next slide, please. And as the product name has been HIMO3, there's a third feature coming with the product, which I already mentioned. It's not just mono PERC, it's not just half cut, at the same time it's bifacial. And that means that the backside of the cell gives you another gain coming from the backside. Let's maybe take a round number of 10% additional gain from the backside. It strongly depends for sure on the albedo of the area, as well as on some design optimizations or design parameters, that you have to have a certain row distance to avoid direct shading, that you have to have a certain height of the module tables. Let's just assume for a quick moment that the bifacial module will have a gain of 10% from the backside. That means as well your currents go up by 10%, and that's where I'm coming from. If you combine then bifacial with half cut, the currents are much better managed if they have two different routes to go either through the upper way of the module or the lower part of the module. As I said, it's how much you gain from the bifacial module strongly depends on the system design and on the albedo. And I've given you some indicative numbers on albedos, depending on you're on dry sand, on grassland, or on some other area. And if you have a certain clearance underneath of the modules and a certain row distance, then you can see on the bottom right graph that mainly the bifacial gain is almost linear with ground albedo. So if we, for example, take dry sand and just assume that there would be 0.2, then you would already have a bifacial gain of at least 7%. If you go to a white sand and to the other extreme and just assume 0.4 as the ground albedo, then you would be something in the neighborhood of 12% of additional gain. Next slide. From the field, I briefly give you some benchmark as well, which is then underlining why we have taken that product decision. What you can see here is, let's say the red bars are LONGi HIMO3 model, the P-type bifacial mono PERC. And left to it is an N-type bifacial product, and right to the red bar is the two other grayish bars is the traditional mono product. On this installation, the products have been installed on a single axis tracker in a desert-like area. And what we could see there is that the LONGi P-type bifacial showed something like 19.27% higher yield compared to the traditional mono. And it showed 1.9% P-type bifacial compared to N-type bifacial, which is underlining what I showed you in regards to the platform technologies, that it seems that the P-type material is not just cheaper, but as well is giving a higher energy yield, which leads to then understandably lower cost solution, lower cost of electricity. Sorry. The next slide is just a little bit of thing where we are proud. There's in 2 years in a row we have been participating in TÜV Rheinland's energy yields benchmarking. This is performed on 5 different locations all across the world. One is in Germany and in US, and one in Japan and India and China. So this is not just for a single location. And TÜV Rheinland Group has performed or measured modules from various suppliers, have created simulation files, used the simulations in PVSys, and then calculated the energy yield for the 5 different locations. The samples have been randomly taken, and we have been now 2 years in a row being the energy yield winner. That means based on the same installed power of the park, let's say 10 megawatt, our produced kilowatt hours have been between 1.5 and 2% higher than the best in the multicrystalline group. This has been just performed with HIMO 1, so this is just mono PERC. If we go to the next slide, the third-party energy yield results performed by PV Magazine. You maybe read this very great magazine. And they published in this month's edition the results from 2019. And what you can see here is as well that the bifacial mono PERC module from LONGi, the most to the left, has delivered the best energy yield, so the most kilowatt hours per kilowatt peak, even beating out, and that's in line with our internal results, the bifacial product based on N-type. So that means obviously we have been taking as well a good decision to go with the platform mono PERC. 3 of our products are in the top 5, and I clearly say that as well from the energy yield, not just from the cost perspective, but from the energy yield, it seems that P-PERC mono outperforms that N-type PERC material. Next and last slide, please. So what we can summarize, what I would like to give you is that it seems that mono PERC appears to be the best technology platform regarding efficiency and cost, and proven by as well the energy output. Mono PERC half-cut delivers lower substring current and losses, and bifacial modules increase energy yield with additional backside performance. Half-cut modules as well reduce sensitivity on partial shading. That's maybe something what I need to emphasize. If you have a bifacial module and you combine this with half-cut, then you could consider to put the rows closer to each other, because that module somehow deal better with partial shading. Half-cut bifacials may allow as well then higher power density, that if you can reduce the row distance a little bit, and as well the clearance, you may get more power per acre or whatever area square kilometer you're using. Combining mono PERC half-cut bifacial in one product delivers the lowest LCOE solution. That's what I was hoping to be able to prove in the few slides in that little 15 to 20 minutes I have time. I would like to give you as well, let's say a heads up that in general the trends go towards 1500 volt designs, half-cut solutions, and bifacial cells. It's at the end, if we have to generate electricity at the lowest prices in the world, that seems to be a very valid path. And from our perspective, we will keep a very strong focus on R&D to ensure and observe that for future improvers, we will meet that lower LCOE criteria. And the difficult thing again remains, what is the right adequate advanced technology for the next step? It seems that as well increasing the size of wafers of cells could be a very viable path. Next slide, or last slide, is just to thank you for the moment, for your time and for your attention, and give the word back to Michael.
Thanks, Winfried. That was actually a point landing time-wise from the presentation side. Thanks so much, Shravan. Winfried, please, to the attendants, please stay with us if you're interested to learn also beyond the pure presentations. We've received a lot of questions on our control panel here. And if you're interested, we will take 15 more minutes to answer them. If you don't have the time, of course, you're happy to, you can, of course, leave to your next meeting. We will have a recording of that and you can do that. In any case, if you want to stay interactive, stay with us 15 more minutes. First question and answers from Shravan. Winfried, please, very short, 1 or 2 sentences so that we can answer as many questions as possible. First question was, do registered participants get the presentations? Yes, we will send them out by tomorrow. Second question comes is on the question of reducing resistance and shading losses, and NWT cells connected with conductive busbars are already installed, and they are of course already an easy and established solution, and have also the potential to transcend into or to move into IBC. So how do you see this evolve versus other technologies? Shravan, maybe in
I think recently I also started hearing that, but before that it was not as strong as this. So in our next report, we will talk to a couple of other people, and then if we really find that this is going to be the trend, we will include in our next report, upcoming report.
Okay. Another question regarding bifacial gains. Actually, they are huge, the variance. So it goes from, I think Winfried said, from 5 to 15 for mono PERC. Shravan even said from 5 to 30, because certain technologies have obviously a bigger bifaciality. So the question is, where do we will see the average in 10 years ahead? So in other words, actually, where will bifacial modules mostly be installed? Winfried, maybe what do you think?
Yeah, for sure, to gain the maximum out of a bifacial product, you have to be in an area which is, I would say, desert-like, where you have a high reflectance from the ground. It's maybe not something which gives you a great gain if you install it on a rooftop, where just the distance from the module to the rooftop is too low, that you would not really have a huge contribution coming from the backside. So I think bifacial is something which will be in most of the cases either on nice buildings where you can use the transparency, and on the other hand, it will be used in huge parks where electricity is generated for the lowest PPA prices.
I think it's also, from my point of view, difficult to say, because in the end, all the newer cell technologies are bifacial by nature, and then it's about changing the backsheet or the whatever the back cover is, and if it's a backsheet, I think there's not any difference. So so they will be simply installed, and whatever comes out of that, we will see. That would be my guess in the near future. Another question is about bifacial modules. Transparent backsheets versus double glass. So far, everyone has been using double glass, but DuPont has come out and is strongly pushing its second generation of transparent Tetlar, and a couple of backsheet laminators are now also offering that product. I think maybe the question is a good question for LONGi, because LONGi has been very close with DuPont, as I understand. I think you're almost exclusively using Tetlar products, at least for the backsheet parts. So what's your take on backsheets versus glass?
You bring me in a bit of a difficult situation. Yes, we have a strategic partnership with DuPont. No, I mean, the industry has been attempting with double glass already many times, and the main approach for double glass was to get the cost down, because it appeared at many times that using glass on both ends would have as well, or mainly have a huge cost advantage. And the only point where the double glass really had, in my eyes, the real justification now, looking not at very hot areas, but in general, is when the bifaciality was joined to the double glass design. So then it made sense to have a transparent backside. Now, with the new developments that the backsheets are getting transparent, it is as well something where you have to be very careful with what is the right approach. Double glass was easier and was available sometime earlier than the transparent backsheets now. But I have to say, we as well investigate on the backsheets, where as well you can print something where in between of the cells you would have some reflectance, and both is as well possible on glass. So I cannot clearly say at the moment glass fall on bifacial will not have a chance, or the other way around. It's just we have decided at a certain point of time to go with double glass because of that was available on double glass. Now glass fall may give an alternative, and we have to reconsider the position if that's still valid, or if we would change or maybe do both.
Okay, yeah, I think so. Maybe from our side, we will soon come out with a new report on backsheets, and we are at the moment still in our research phase, and are obviously also discussing how the demand is for transparent backsheet solutions. So more about this in one of our upcoming reports, and that will be in a month or so. Another question is, how do you foresee adhesives as a substitute for soldering? Also, especially when we look at HJT cells, maybe Shravan?
Yeah, I think it is definitely one of the route followed. I mean, it's one of the alternates, but you know, heterojunction is still at the starting phase, and right now, many studies point towards smart wire connection technology, which is really taking care of everything like silver saving. Then you have low temperature processing, everything is taken care there. But if you are with adhesive, it is still some trade-off. You know, you still have to go for 5 busbar, then you won't get the silver saving, all these benefits and resistant losses saving, and you cannot reduce the finger width. So these are some kind of bottlenecks it has, but yeah, it really depends on the stage of the company where they want to be. If they really want to jump to the really next level, then SWCT is available. If someone want to really go progressively, you know, change some parts of the interconnection with the available technologies, I think conductive adhesive has a promising you know, benefit. Yeah, but conductive adhesives, on the other hand, are also getting cheaper.
Okay, what about shingled cells? There's a question. So due to overlap of cut cells, so how much area and percentage of the cells is covered shaded, and what does that mean actually for final for the final power ratings in comparison to other technologies?
No, power ratings are really good, because if you see any shingle modules, they have really very high power, but exactly overlap the overlap width. I think it's a question of also IP that I'm not completely into Shingles, but that's what I was told. Like there is how much you cover, how much is the overlap is what it covers, but it's compared to you know, the shading what you get from the bus bars. I think this is negligible.
Okay, what else do we have? Okay, question here. Is it possible to make a bifacial model if you're starting with NWT, IBC, or cat telluride thin film? If not, do these three platforms get driven into applications where there is no available light from below? Another question, in other words, will the bifacial become the dominant approach, which of course can cause some issues for companies that have that are really focusing on these particular technologies?
Yeah, so I think. Oh, sorry, please, Winfried.
Yeah,
maybe
Winfried, you first.
Just a short comment. Maybe you go into more detail. Sorry, Shravan, good, go first.
Okay, so I think for as far as the IBC is concerned, you know, if someone moves there and then IBC is not completely blocks on the rear side, so it also, so there are some approaches where you can still have, I think 60 to 70% bifaciality, comparable to, that's more or less comparable to PERC. So it's not a completely no-go situation. I think bifacial is more enabler of any technology rather than being a competitor for a technology. So it's a common intersection for any technology. It can embrace anyone and make it better.
Yeah, what I wanted to add is just the fact that it's a bifacial compared to a single-sided cell in the short run or maybe the mid run. It will be the same like with the multi-mono parity, that bifacial cells are just roughly the same cost than the single side, and this will have maybe as well an impact then which technology can then take a bigger benefit from this than others.
Okay. So just quick, let's, I think the questions are getting more and more, but let's do 3-4 more minutes. It's interesting. We still have over 2/3 of the participants that originally is registered are staying with us. So nobody seems to be bored, but, or hardly anyone. So just a few more answers to the big pile of questions we still have. The question here, do you have a pro-con overview of the different technologies regarding bankability? I think that goes to you, Winfried, because you're looking, of course, into all of this. So what are you seeing, especially bifacial coming now, Halfcell is coming now, looks actually pretty easy, but actually I think it's not so simple, because if you are not cutting it properly, I think you can run into some resistivity problems at the edges. At least that's what I'm hearing from from the field. So so maybe can you just give us some background on?
Yeah, I can try. I mean, banks in general, they hate everything which is new, where they don't have a 10 years track record and everything is safe. So it's a kind of fearing the risk, and it's if there is something new, like maybe 1.5 years ago when we started to start with bifacial products, the big question for most of the banks is, do you have reference sites? And they said, yeah, you're maybe also one of the first ones, and that's what you should never tell a bank, that you're one of the first ones. And even if you are a reliable company and you can prove a lot of things, banks in general hate things which are new. But at the end, they are, depending on the bank, they are learning quite fast, and it's always good if you can prove that there are more than one company going this technology road. if you can say Byfacial is nothing really exciting anymore from let's say from production point of view, it is fully under control, and there's a bunch of companies out offering Byfacial solution, then it's easier to convince a bank. But if you're alone, if you're really starting first with whatever technology that might be, the banks are very conservative.
Okay. What about just a few more? Okay, I think I think that's an interesting question, because I think we should discuss maybe LTID, PID for any advanced module technologies. What are you hearing, or how are you working with it? Probably that's going to Winfried.
Yeah, I can say for mono PERC is that LETID, that is LID at elevated temperatures, is not an issue at all for our mono PERC solutions. We have done very much of tests, internal and as well external. And what we could found in regards to that LETID, which is measured at the end by current induced degradation, is that it's in the neighborhood of 1.5%. So really not significant. There have been other suppliers out in the market which have had major issues with LETID, which seems to be linked to wafer purity, where mono in general already has a huge advantage over multicrystalline. And maybe my market insight is not complete, because I'm mainly traveling across Europe. I've not really seen, or most of the issues the other direction related to LETID are linked to multicrystalline products, and most of them to let's say 1 or 2 suppliers.
Okay, we still have over 50% of the attendance, but I think we're now 15 minutes over. I think we can accept that as an academic 15 minutes. So I would like to do, I would like to say thanks to Shravan, thanks to Winfried, thanks to LONGi for supporting and sponsoring this event. Thanks to all the sponsors of our advanced module technology report. If you have any specific questions, please get in touch either with Shravan or with Winfried. They are happy actually to answer it also on an individual basis. We of course will try to address that in one of our upcoming reports, all the questions wherever they fit. And please stay tuned. Next week, we will publish our heterojunction report. If you're spontaneous, are related to the technology and want to get some message out, the report is done, but we can still fit some advertising in the report. That's the one message I have to say. Thanks for staying with us, and we let you know as soon as any reports come out, or when the next webinar will be held. Thank you so much. Have a nice evening. Have a nice afternoon wherever you are. Bye bye.
Thank you very much. Bye bye.
Bye bye.